my name is Ashraf, and this is our IDP project. Today we're going to talk about an amphibian house. Me and my group mates, Hamid Rasco and Husna Khairia. So in Malaysia, normally when there are floods, houses are mostly getting flooded too much, right? There's so much water into the house and stuff. So we want to prevent that, or at least make it less happen, right? So our project, our idea is called an amphibian house. So the idea about amphibian houses are that some of them have walls, some of them have like pits below them, so the water like goes in below the house. But ours is that to raise the whole house above the ground, right? So we have three systems, not three systems, three separate parts: the house, the floating mechanism, and the hydraulic system. So my part is, I'm going to talk about the house, and I'll leave the rest to my teammates. So this is our prototype of the house, right? It's pretty small, of course, because we're making a project. So this is how it looks like. This is how we imagine a two-story house that is on the ground that we can try to prevent from the flood, right? So these materials are, this is hard cardboard for design, and we use silicone to seal it up. So if we do the experiment and water floats above, if the experiment fails, it doesn't go in the house and ruin the whole house, right? So yeah, basically this is the cardboard, and we use silicone, and we have other materials that we're going to show you in the video. Okay, so the house dimensions are 3 meters by 6 meters. This is what we found that is mostly common in Malaysia, the dimensions of a house, of a normal house or a small house. So this is 3 meters and this is 6 meters. And this is the platform that we have the house floating on. And the PVC pipes are going to be below the platform. So we're going to raise the whole platform with the house, with the PVC. So the PVC, we measure that it's sufficient enough to raise the whole house above the water, if there's enough amount of water below it. Plus, the hydraulic system will act also as a support for the PVCs. So if we don't have enough buoyancy below the house, the hydraulic system will act with the buoyancy to raise the house above the ground, to provide it from flooding, right? And so if we put this without any supports on above the water, right? It's not going to be stable. Of course, it's gonna swim because the flood has waves and not stable water. So we will add also supports on each corner. For every corner has a support. So it goes only on 2 ways, up and down. And yeah, that's our project about the house.
Hello everyone, my name is Husna Khairia binti Abdul Hamid Khair, and as my friend previously already explained about our prototype on the amphibious house, now my part is I will explain more on our flooding mechanism. So let's start with the main component for our flooding mechanism. The first component is PVC pipe. The main purpose of choosing PVC pipe is that its ability to float above water, and the second thing is that our purpose to choose PVC pipe is to aid the house to rise when the flood comes beneath the house. So yeah, that is the purpose why we choose PVC pipe. Now I will explain more on the prototype, how the flooding mechanism looks like. So the first thing is the water bottle. Here it represents the PVC pipe, as the shape looks like a pipe, and then bottle can float above water. And then how it actually works is when flood coming, basically this bucket contains the water where it represents the flood water. So when it comes beneath the house, so the floating mechanism will float the house. At the same time, hydraulic system also will help the house to float. Okay, so as it rises, at the same time it will rise the house. Yes, it looks like this. So this is how the floating mechanism works for our prototype. In the next part of the video, my friend will explain more on the hydraulic system.
Hello, Doctor. So I'm going to be explaining the third and final stage of our prototype, which is the hydraulic system. So our basis is on the Pascal's principles of a hydraulic lift, where any change applied to the pressure of an enclosed fluid is transmitted to all parts of the fluid and its encountered walls. What this basically means is that this allows a small force applied to a small area to be converted to a large force and a large area. This is the basis of a hydraulic system. And based on the figure we see here, F1 and A1 have a direct relationship with F2 and A2, where F1 represents a small force and A1 a small area, and by differences between the change and pressure of the fluid, we can actually achieve F2 and A2, where by doing the calculation, we can use a small force to operate a larger force and a larger area. Alright, so here now we're going to test the hydraulic system of our prototype, where the house is placed on the bigger piston, and we're going to place a smaller weight on the smaller piston. Hopefully the differences in pressure will allow the smaller piston to come down while lifting up the house, which is placed on the bigger piston. And hopefully we can approve Pascal's principles. So we're going to place the smaller weight on the smaller piston without applying any further pressure. You should see that it is in fact lifting up the house, even though the weight of the one on the smaller piston is lower than the one on the house. And so slowly but surely, all of the liquid has been transferred from the smaller piston to the bigger piston. And that proves that on a much more bigger scale, this in fact can work.